You think objects move because something is pushing them. You imagine motion as an effect, a cause applied, a force doing work. You picture a hand letting go of a ball, and you think the motion should fade slowly. Naturally, because nothing is touching it anymore, that feels obvious. It feels responsible. It feels like common sense. But it's wrong. You've been trained to believe that rest is natural, that motion is borrowed, that objects must be kept alive by forces or they will stop. You don't question this picture. You live inside it. You think a moving object is asking a question. What's pushing me right now? But that question itself is flawed, because the universe does not treat motion as something that needs permission. It treats stopping as the strange thing. This is not a technical mistake. It's an intuition mistake. And Richard Feynman didn't fix it with equations. He fixed it by removing a mental image you didn't know you were carrying, an image that makes motion feel expensive. Fragile, temporary, it isn't. And once that image is gone, you can't put it back. You were taught that rest is normal. Not explicitly. No one sat you down and said it out loud. It was taught the quieter way, through experience. You push a book across a table, it slows, it stops. You throw a ball, it arcs, it falls, it comes to rest. Again and again and again. From this, your mind extracts a rule. Motion is temporary, rest is permanent. This feels earned. It feels empirical, but it isn't. What you are really observing is not nature in isolation. You are observing nature smothered. Every motion you've ever seen is drowning in friction, air, surfaces. Internal resistance, heat leaking away. You live inside a universe that constantly interferes, and interference masquerades as law. So you grow up believing that objects want to stop. That motion is something you must maintain. That stillness is the default state. This is wrong, not subtly wrong, foundationally wrong. Rest does not have a privileged status in physics. It just feels privileged to you because you are embedded in a noisy environment. Imagine, not calculate. Just imagine a world with no air. No surface roughness, no internal friction, no microscopic drains siphoning motion away. Now slide the book. There is no slowing, no fading, no natural return to stillness. The motion does not die. It does not need encouragement. It does not ask for energy. It simply continues. This is the part your intuition resists, because continuation feels like something that should require effort. But effort is something you experience, not the object. Your muscles burn when you push, so you project that strain onto the universe itself. You think motion must be tiring. It isn't. Stopping is what requires explanation. When the book stops on your table, something has happened to it. Something physical, something violent at microscopic scales. Atoms collide, energy is redistributed. Order dissolves into heat. Stillness is not peace. It is aftermath. But you were trained to see it backwards. You see motion as an event, rest as a conclusion. Physics sees motion as persistence, and stopping as an intrusion. This reversal is not philosophical. It is not poetic. It is operational. Once you remove the lie of natural rest, a deeper discomfort appears. If motion doesn't need to be caused, then why do forces exist at all? That question cannot be answered yet, not until another intuition is taken away. Your intuition was not built by laws of physics. It was built by floors, by roads, by air, by skin touching fabric, by wheels that grind, by hands that slip. You have never experienced motion without resistance, not once. So when things slow down, you don't see an interaction. You see a rule. You think the universe is applying brakes. But friction is not a background feature of reality. It is a local accident, a side effect of structure. Friction exists because matter is lumpy, because surfaces are not smooth, because atoms have fields that catch and tangle, because energy has places to hide. None of this is fundamental to motion itself, and yet friction dominates your education. You are shown inclined planes, rolling carts, sliding blocks. Even when teachers say, ignore friction, your brain doesn't, because friction is the only thing you've ever trusted. It feels honest, predictable, comforting. A world where motion just continues feels irresponsible, uncontrolled, almost fake. So your mind adds an invisible rule. Everything slows down eventually. This is not a law of motion. It's a law of where you live. Feynman was blunt about this. He didn't treat friction as a correction. He treated it as the source of the confusion. Because once friction is present, it does something subtle to your thinking. It hides inertia. Inertia is not a force. It does not push back. It does not resist. It simply does nothing. And nothing is hard to notice. When an object keeps moving, you don't feel it. You feel the effort when you start pushing. You feel the effort when you stop it. So your nervous system learns a pattern. Change feels active. Continuity feels passive. And passive things feel unimportant. This is how friction hijacks your intuition. It makes change visible and continuity invisible. You never ask why a puck on ice keeps sliding. You only ask why it slows down. But that question assumes slowing is normal. It isn't. Slowing is evidence that the environment is stealing motion away. Quietly, relentlessly, the universe is not telling objects to stop. Their surroundings are. Remove the surroundings, and something unsettling happens. There is no longer a reason for motion to end. No preferred speed, no finish line, no natural zero. Which leads to a disturbing realization. If friction is the storyteller you've been listening to, then you've never actually heard motion speak for itself. To hear it, everything else has to go silent. That is exactly what Feynman does next. Feynman's move is not to add complexity, it's to remove it. He asks you to imagine a universe stripped of distractions. No air, no surfaces, no friction, no heat loss, no background noise pretending to be law, just space and an object. You release it. Nothing dramatic happens. That's the point. The object does not slow. It does not search for rest. It does not correct itself. It does not ask where it should be going. It simply keeps moving. At first, this feels incomplete. Your mind waits for the explanation. The hidden mechanism. The invisible hand. But nothing arrives. Because there is nothing to arrive. Feynman insists on something that feels almost offensive to intuition. Motion does not need maintenance. There is no fuel being burned, no force quietly working in the background, no cosmic effort keeping things going. The object is not doing anything. It is just not being interfered with. This is where the discomfort deepens. You are used to asking, what causes this motion? But in an empty universe, that question has no traction. There is no preferred state to explain. No destination the object is trying to reach. No rule being followed except one. Whatever is happening keeps happening. This is not a statement about energy. It is not a statement about momentum. It is a statement about the absence of reasons. Feynman's insight is that explanations often sneak in because we expect drama. We expect events. We expect causes layered on top of causes. But sometimes the correct explanation is that nothing intervenes. In the empty universe, motion is not an event. It is a condition, and conditions don't demand causes the way changes do. This quietly erases a habit of thought you didn't know you had, the habit of asking for permission. You think motion must justify itself, but justification only appears when something changes. Speeding up needs a reason. Slowing down needs a reason. Turning needs a reason. Continuing does not. This is where intuition collapses, because your language betrays you. You say an object keeps moving, as if effort is being extended, as if something could fail, but there is no keeping. There is only not stopping. And stopping in this universe is impossible, because stopping would require an interaction, and there are none. Once you accept this, a dangerous thought appears. If motion persists without cause, then force cannot be what you thought it was. Because force was supposed to be the thing that makes motion happen. And now motion is happening without it. That means force has been miscast, not as the cause of motion, but as the cause of something else entirely. This is where the real inversion begins. You were taught a simple equation. Push equals movement. More push, more motion. It feels intuitive because it matches effort. You push harder, you strain more, something changes. But this is where intuition lies by analogy. Your effort is not the object's experience. In Feynman's empty universe, apply a force to the object. Not to start it moving, it's already moving. Apply it sideways, something changes. The object does not obey the force by moving. It was moving already. What changes is how it moves. Its direction bends, its speed shifts, its path curves. Force does not create motion. It creates deviation. This is the inversion that breaks the old picture. Motion is not the response. Change is. Force is not the reason an object moves. It is the reason motion fails to stay the same. Once you see this, a lot of familiar language collapses. You stop saying the force keeps it going. There is nothing to keep. You stop imagining force as a motor. It is not an engine. It is a disturbance. This is why Newton's first law exists at all. Not to describe motion, but to protect it. The law is not saying what objects do. It is saying what they do unless interrupted. That's a very different kind of statement. It says, if nothing acts, nothing changes. Not nothing happens, but nothing changes. This distinction is where most confusion hides. Because your intuition does not track sameness well. It only notices contrast. A car accelerating feels dramatic. A car cruising feels boring. So you attribute reality to the drama. But physics is indifferent to drama. A constant velocity has no physical signature, no internal marker, no detectable difference from rest except relative to something else. So when you say force causes motion, you are mislabeling the effect. Force causes acceleration, which is a change in motion. Motion itself does not sit waiting for permission. This reframing is unsettling because it removes agency from force. It downgrades it. Force is no longer the star. It is the editor. It cuts, it redirects, it interrupts, and once you accept that, another intuition quietly breaks. You thought inertia was resistance, something pushing back. But if force doesn't create motion and motion doesn't need to be defended, then inertia isn't doing what you thought it was doing at all. It isn't fighting change, it's simply refusing to participate. That refusal is not active, it is not a struggle. It is the absence of intervention, and that absence has consequences, uncomfortable ones. You probably imagine inertia as stubbornness. An object doesn't want to change, it resists, it pushes back. This language is everywhere, and it's misleading. Inertia is not a force. It does not act. It does not oppose. It simply does not care. When an object continues moving, inertia is not doing anything. There is no mechanism engaged, no effort expended. Inertia is what you get when nothing interferes. This is why it feels so empty as an explanation, because it isn't one. You are used to causes being active, to something happening, but inertia is a description of what fails to happen. No forces act, so nothing changes. That's it. This becomes disturbing when you look closely at what resistance actually means. When you try to accelerate an object, you feel effort. When you try to stop it, you feel effort. So you assume the object is pushing back. It isn't. What you are feeling is your own interaction with it. The force you apply must go somewhere. It changes the object's motion. Your muscles register strain, so your brain invents opposition. But the object is not resisting. It is complying perfectly. It changes its motion exactly as much as the force dictates. No more, no less. If it were resisting, it would do something extra. It doesn't. This is the quiet shock of inertia. It removes personality from matter. No preference, no tendency, no desire for rest or motion. Just continuity. And continuity only feels mysterious because you keep expecting something to happen. Feynman emphasized this emptiness deliberately. He refused to dress inertia up, because once you do, you start inventing explanations where none are needed. You imagine inertia as a stored property, a kind of internal weight, something pushing outward in time. But inertia is not inside the object, it's in the law. It's a statement about the universe's indifference. If no forces act, the object does not evolve, not because it can't, but because nothing tells it to. This reframing is hard to hold on to because it undermines cause, and it affects instincts. You want reasons. You want agents. Inertia gives you none, and this has a consequence that feels almost offensive. The universe does not notice constant motion. There is no signal for it, no marker, no clock that ticks faster or slower, which means speed itself is strangely unimportant. That idea breaks another intuition, one even deeper than rest. You think speed is a fact, a number the universe can read, a condition an object carries with it, but constant speed leaves no trace. There is no experiment you can perform inside a smoothly moving system that reveals how fast it is going. No internal signal, no strain, no change. If nothing accelerates, nothing is happening. This is not a limitation of measurement. It is a statement about reality. The universe only responds to differences, changes, interruptions. A system moving at a constant velocity is indistinguishable from one at rest, unless you compare it to something else. And comparison is not absolute, it's relational. This is why the idea of true motion quietly dissolves. You imagine an object moving through space, carrying its speed like a tag, but space does not register that passage. There is no background grid keeping score, no cosmic speedometer. From the object's own perspective, nothing is changing. No energy is being spent, no effort is required. This is unsettling because it removes motion from the category of events. An event is something the universe can notice, speed is not. Only acceleration has physical consequences. Only changes in motion create effects. This is why you feel forces only when something changes. Why turns press you into seats. Why sudden stops hurt. Those sensations are not evidence of motion. They are evidence of interruption. And once again, friction has been lying to you. Friction creates constant accelerations, tiny ones. Everywhere it makes speed decay. It makes motion feel temporary. It makes the universe seem opinionated. But remove friction, and speed becomes invisible, which leads to a strange inversion of importance. Rest is not special. Motion is not special, only change is. This quietly dismantles another habit of thought, the idea that the universe prefers simplicity. You think zero velocity is simpler than non-zero velocity, more stable, more natural, but the laws do not care. Zero is not favored, it is not selected, it is not returned to, it is just one number among infinitely many. This realization leaves you in an uncomfortable place. If motion does not need to be caused, if rest is not privileged, if speed is invisible, then the universe is not actively managing the future. It is merely allowing continuity. And that is a very different kind of cosmos than the one you were raised to imagine. Feynman stops here, not with an answer, but with a silence. At the end of this chain of removals, very little is left. No natural rest, no need for motion to be sustained, no force creating movement, no resistance built into matter, no universal awareness of speed. What remains is continuity, not as a principle, not as a mechanism. As a default, the universe does not push objects forward in time. It does not shepherd them towards stillness. It does not check whether motion is justified. It simply does not interfere. This is where Feynman refuses to comfort you, because once you accept this, explanation runs out in a quiet way. You can ask why forces change motion. You can ask how interactions work. Those questions still have structure. But if you ask why motion continues when nothing acts, there is no deeper answer. Not because physics is incomplete, but because the question assumes something needs to happen. Nothing does. The laws are not instructions being executed. They are constraints on what is allowed to change. And when nothing violates those constraints, the universe remains indifferent. This indifference is not cold, it is not hostile, it is empty, and emptiness is hard to sit with. You were taught to imagine reality as active, full of processes, full of causes marching forward, but at its base, motion reveals something quieter. The universe does not prefer outcomes, it does not optimize, it does not tire, it allows. An object in motion is not being carried, it is not being helped, it is not being sustained, it is simply not being stopped. That reframing is small in words and enormous in consequence, because once you stop asking what keeps things going, you start noticing how rarely anything actually changes. And in that stillness, disguised as motion, there is no final explanation waiting. Only awe, not the loud kind, the kind that appears when a familiar question dissolves and leaves nothing behind to replace it.